One day, the universe will die. But why? How? Will it die forever? And how do we know? First, the universe is expanding. Not only that, but the rate of expansion is accelerating. The reason? Dark energy. Scientists believe dark energy is a strange phenomenon permeating the entire universe. Until 1998, we thought the universe expanded like a ball tossed into the air. The ball would fly upward for a while but eventually fall back down. But the actual expansion of the universe is accelerating. It is like you toss a ball into the air and it just keeps going and faster. Where does this acceleration come from? We don't know, but we call it dark energy. Einstein first conceived this idea, though he later dismissed it as absurd. Yet today, astronomers find the concept plausible. The problem is that all this remains highly theoretical, and we have no clue what dark energy is made of. However, several theories exist, and from these theories, 3 scenarios for the universe's end have been proposed. The Big Rip. Since its birth, the universe has been expanding. Due to some unknown principle, new space is constantly being created everywhere, all the time. The space between galaxies keeps growing, causing them to drift farther apart. Expansion also occurs within galaxies, but here, gravity remains strong enough to hold them together. In the Big Rip scenario, expansion reaches a point where gravity can no longer counteract the effects of stretching space. The result is the Big Rip. First, only large structures like galaxies will be torn apart, as space expands so rapidly around individual objects. Next, massive celestial bodies, black holes, stars, and planets, will perish. Their gravity will no longer suffice to hold their form. They will disintegrate into their constituent elements. Finally, the expansion of space will exceed the speed of light. Atoms themselves will be affected and begin to disintegrate directly. Once space expands faster than light, no particle in the universe will be able to interact with another. The entire cosmos will disintegrate into countless solitary particles, drifting through an eerie eternity where they can never touch one another. And you thought you were lonely. 2. Heat death or cold death. Simply put, the difference between the Big Rip and heat death lies in the fact that in the heat death scenario, matter remains intact, and after an extremely long period, transforms into radiation. Meanwhile, the universe continues to expand infinitely. But how does this come about? Let's discuss entropy heat. Every system tends toward maximum entropy. Consider a cup of latte macchiato. Initially, it has regions of varying temperatures, but it gradually cools until uniform. The same applies to the universe. As the universe grows larger, matter slowly decays and disperses. At a specific point in time, after countless stellar births, all the gas clouds forming stars will be depleted, plunging the universe into darkness. The last stars will die. According to Hawking radiation theory, over trillions of years, black holes will gradually degrade and vanish. When this process completes, only a sparse gas of photons and light particles will remain until decay. At this point, all activity in the universe ceases, entropy reaches its maximum, and the universe experiences eternal death. Unless, theoretically, after an immense span of time, spontaneous entropy reduction might occur. This could stem from so-called quantum tunneling, potentially triggering a new Big Bang. 3. The Big Crunch and Big Bounce. This is the most exciting scenario. If dark energy is weaker than we imagine, or if over time gravity becomes the dominant force in the universe, the expansion rate will slow and eventually halt after trillions of years. Thereafter, it will reverse. Galaxies will coalesce and converge toward the initial state of the universe, growing ever smaller. A smaller universe implies the hottest universe, reaching extreme temperatures where everything collapses into a single point. During the Big Crunch 10,000 years ago, the cosmic microwave background radiation would be far hotter than the surfaces of most stars, meaning they would be cooked by their surroundings. Minutes before the Big Crunch, before the supermassive black hole devours everything, atomic nuclei would be torn apart. Finally, all black holes merge into a supermassive black hole containing the entire universe's mass. In the final moment before collapse, it devours the universe, including itself. The Big Bounce theory posits this has occurred countless times, with the universe cycling infinitely through expansion and contraction. Wouldn't that be nice? So, what exactly happens when the universe dies? Currently, heat death seems most likely, but we still hope this theory of eternal death is wrong, that the universe will restart. We don't know either way. So, let's assume the most exciting theory is true. By the way, we have a Twitter account. Subtitles provided by the Amara.org community.